Hi, my name is Igor. I'm the co-founder of Lightly, and today I have the pleasure to talk to you about our data curation product, LightlyOne. When we were working on different computer vision projects ourselves, we very often faced one big issue. We had a lot of data available, but only limited labeling budget and labeling time. So we had to figure out what subset we can actually work with. And typically these subsets were around 1% of the available data. So as you can imagine, we had to figure out how to pick the best 1%. And this is exactly why we built LightlyOne. Today, I want to give you a quick walkthrough how LightlyOne fits into the existing computer vision pipeline and how you can use it to create your very first dataset. We have here already an overview of the pipeline. As you see on the left, we start with the data storage layer, which can be a folder on your local machine. It can also be a cloud storage provider like Google Cloud, AWS, or Azure. We're agnostic and compatible with all of them. The next step is already LightlyOne. So as you see, LightlyOne directly connects to your storage. LightlyOne can process millions of images or thousands of videos automatically for you to find the best 1%. Once processed, LightlyOne can forward the selected data directly to your labeling team. Once the data is labeled, you can train your models and deploy them. If you have a trained model in place, we can also use the model predictions to further refine the selection step by using active learning. Let me give you a quick walkthrough how you can use LightlyOne on a real dataset. We have a Python SDK that you can install and you can use to connect to our API. So you import the different dependencies, you authenticate with our API client, and then you already create your dataset. Important, LightlyOne supports images as well as video datasets. If you work with videos, you do not have to extract all the frames manually yourself. LightlyOne can directly process videos and extract the relevant frames only after the selection step. So you're going to save a lot of time and data storage. Once we've created the dataset, we configure a data source. LightlyOne works with two different folders. Basically, one is the input data source. This is a read-only bucket. And the second one is the Lightly data source. This is basically where we are allowed to store temporary information such as model checkpoints or thumbnails, or also where you would provide additional metadata or predictions. All of that data always resides in your own environment, so Lightly never stores sensitive data on the Lightly platform. If you would work with Azure or Google, you would only have to change this part of the code. As a next step, we configure the data selection job. So we basically tell Lightly how data should be selected. In this case here, we set some constraints, like for example, we only want 300 images to be selected. So no matter how large the input is, if it's thousands of videos or hundreds of thousands of images, the output will always be 300. As a next step, we configure different data selection strategies. You can add as many as you want. In this case here, we add one strategy that uses embeddings to diversify the images. So our goal is basically to have a very diverse subset in the output. As a next step, we also use model predictions to balance across the categories of the classes. So basically, if some of the classes are overrepresented or underrepresented, we try to equalize them out. So underrepresented classes should be prioritized. Finally, we can look at the model predictions and the active learning scores. So here we prioritize data where the model might be more uncertain. Overall then, these three strategies are combined and the LightlyOne algorithms are working to find the top 300 images. All the processing runs in a separate Docker container, which you can run on any cloud provider or local compute infrastructure. We usually recommend to run this on a GPU machine to speed up the processing time. Once the data is processed, you can use our UI to understand how the final subset looks like. In this case, you can look at the 300 images. You can also get additional information, such as, for example, what kind of data has not been selected. We have a very thorough PDF report with additional information about that. In the UI itself, you can scroll through your dataset. As you see, it's always loaded directly from your cloud bucket, and you can also sort the dataset based on different metadata. You can provide your own metadata as well, so you can filter the data based on whatever information you have available. If you find some data that is not good, we can select them and we can remove them from the selected subset, so we do not send this data to the data labeling team. What we can also do is we can look at the dataset in an embedding view. So here we look at the different images clustered in a vector space, and as you see, similar images are close to each other. We can also look at the same data set on the object level. So here we look at the images of the objects. So whenever there's a bounding box, we would crop it out, feed it through a vector embedding model, and then project it into the 2 dimensions, as you see here. This is great to see if there are potential false positives. As you see here in this cluster, there is clearly a false positive in the cluster of traffic signs. So as you see, most of the images are traffic signs. However, here we have 2 times the Lidl logo, which is like a supermarket chain. So this is not what we want. If you now want to specifically emphasize this kind of cluster, we can also just select it or look at it in more thoroughly. This is great to also see if there are any outliers or special objects in your data set that you would not expect. So you can also give feedback to the data collection team. Finally, once we're through with inspecting the data in the UI, we can just export the data set. Either we can export a list of file names or in any different format we support. We can do all of that also in the Python API directly. So the UI is more like an optional step here. Let me quickly recap what I shared today. So as a very first step, LightlyOne is a data curation product that fits into any computer vision pipeline. It works directly on the data storage layer. So typically it's connected between data storage and data labeling, and it works on unlabeled data sets. You can configure LightlyOne with a Python API, and we have a very thorough interface to specify how data should be selected. And finally, we have a UI that allows you to refine the selection, manually create data, or then directly send it out to the data labeling team if you do not want to use our Python API. I hope this gave you a good overview. If you have any questions, do not hesitate to reach out.